8.6. Example 1, they give us 4 to the 3x equals 8 to the x plus 1. What we are trying to do is figure out what x equals. Now, you could sit here and guess and check and possibly come up with an accurate answer. Okay? Obviously, that's going to get harder the further you go because that's example 1, so that's going to be the easiest one, right? So, what we want to do is we want to try to make these two bases the exact same thing. Now, the only way we've done that is with exponents. So, can I change them into the same thing using exponents?
Yeah.
What is 4 with an exponent? What can I change it to? I can change that to a 2 squared. And then that's to the 3x. Can I change 8 to a 2? What? 2 cubed, and then to the x plus 1. Everybody good so far? Okay. Power of a power. I do what? Multiply. So I actually have 2 to the 6x. And on this side I have 2 to the 3x plus 3. You need to multiply it to both of those in that case. Okay? So I've went through this process. My bases are the same now. Now the reason why we want that, if my bases are the same and I want everything to be equal, don't my exponents have to be equal to each other? Yeah, because if I got this to equal 2 and I got this to equal 3, then you'd have 4 equals 8, and that doesn't make any sense. So if this whole thing equals 2, this whole thing also has to equal 2, correct? So I know, because of that reasoning, that 6x has to be the same as 3x plus 3. They have to be equal to each other. Right? Everybody okay? So then we just start solving this. Subtract 3x. I get 3x equals 3, x equals 1. Okay, again, that's the easiest example. So they're going to be a little bit harder. If I happen to have maybe this was a 9 and this was a 27, what would you change your bases to? A 3, because I could write it as 3 squared and 3 cubed. Okay, so you got to break them down. We're trying to make our bases be exactly the same, because then if our bases are the same, I can just set my exponents equal to each other. Should we do another example of that? Let's do another one. I have 2 to the 4x, and I have 32 to the x minus 1. Now, I obviously look at that. I can't change that 2, can I? No, it's stuck there. Can I change the 32 into a 2? 2 to the what, Mitch? I thought you said third. I was like, okay, 2 to the 5th. So I have 2 to the 4x equals 2 to the 5th to the x minus 1. Which Lorelei over here gives me what? Good. Oops. And Devin, since my bases are the same, I can set up what? If my bases are the same, these have to be what to each other? Aspen? Equal. So I do 4x equals 5x minus 5. And then from here I'm just solving. Subtract 5x. Negative x equals negative 5. X equals 5. Now, for example 2, things change a little bit. This is getting closer into the reason why we're doing logarithms. They give us 2 to the x equals 7. So right now they're asking us 2 to what power equals 7? Right? Any idea? No. I have no idea. Obviously it's going to be some decimal. Probably between 2 and 3. Because 2 squared is 4 and 2 cubed is 8. So it's going to be a decimal probably closer to 3, but I don't know what it is. Do you agree with me that if I have this scenario, this cancels? Okay? So what we're going to do is we're going to use log base 2 to get this to come down. Okay? But I know if I do something to the left side, I have to also do it to the right side. Okay? So in this case, I'm going to do log base 2 of 2 to the x equals, I did it to the left side, so I need log base 2 of 7. Here, cancel. I get what on the left side? X equals, can I mess with this? Do I know what that is? I don't know what that is. Thank you. Okay. But in the last lesson, we learned a formula that allowed us to solve any logarithm that we ever came across. What was it called, though? Change of base formula. So, like Jack just told me, I'm going to change my base to 10. So I have log base 10 of 7 divided by log base 10 of 2. And we can do what? Just plug that in our calculator, right? Log of 7 divided by log of 2. .81. Okay, so what we're doing is if we have something that we can't solve or don't know how to solve, here, use your logarithm to get it to cancel out. And then whatever you do to that side, you got to do to the other side. Is it always going to be log base 2? No, it's going to be log base whatever that number is, right? Okay, so let's do another example of that. I don't like the example they gave me. Let's make one up. 7 to the x equals 132. Anybody know what power to raise 7 to get 132? I don't. Probably. So what log base do I have to use? I have to do log base 7 of 7 to the x equals, and then Carissa, on the right side I do what? Of 132. Good. On the left side I get what, Devin? X. I can go ahead and split this up right now. What goes on top? 132 divided by log of 7. What is it? 2.51. So you can see how we're using these logarithms. That's a problem that we never would have been able to solve before we learned logarithms. Questions so far? I got one more example for you, and then we'll do some problems for the rest of the class. Example 3. Okay. I have 10 to the 2x plus, minus 3 plus 4 equals 21. So it looks a lot like past equations that we've solved, except our exponent is where our variable is at. Our rules of all of our equation solving that we've always had still apply. You need to get this by itself. So what do you got to get rid of first? Yeah, you got to get rid of that 4. So let's subtract our 4. So I have 10 to the 2x minus 3 equals, 17. Okay. What do I have to do to bring that exponent down, though? Well, okay, let me rephrase this. You do have two options, I guess. You can either bring that exponent down, or you can change this to a 10, right? Because then that would be able to set my exponents equal to each other. But can I change that to a 10? No. So what do I need to do to bring this down? What log base do I need? I need log base 10. So I have log base 10 of 10 to the 2x minus 3 equals log base 10 of 17. So on the left side, cancels, and I get 2x minus 3 equals, now, is this a number? Can I do that in my calculator? Yeah, because it's already a base of 10. 1.23. And now from here I just have my equation. So I add 3. I get 2x equals 4.23. X equals 2.125. Okay, using the same idea from the last example, okay, you have to use the same base as the side you're trying to drop down. Do one more of those. I have 5 to the x plus 2, that's not going to be right, plus 3 equals 25. Jack, when you're ready, tell me what my first step would be, please. I would subtract the 3. So I'd have 5 to the x plus 2 equals 22. Yeah. Okay. Alex, what does my base have to be on my logarithm to bring my exponent down?
Like what number? Or like
Yep. As this, right?
yeah.
So it's going to be log base what? 5. So I have log base 5 of 5 to the x plus 2 equals, if I do it to that side, do it to the other side, log base 5 of 22. On the left side I get x plus 2. On the right side, let's go ahead and use change of base formula. So I have log of 22 divided by log of 5. This is by itself 1.92 x plus 2. So now I subtract, I get x equals negative 0.08. Huh?
X plus 2 divided by x plus 3.
That was the last problem. Did I do that right? Okay. The big rule, use whatever base on your logarithm that would cancel out, right? And then obviously we learned change of base formula for this reason also. So you can do that. Okay. Any questions? Okay, let me know if you have questions while we're working through. I want you guys to start on page 505. And we will do 19 through 41 odds.